Hello everyone, welcome back to our YouTube channel Ignited Medicals. Today will be the continuation part of the previous classes of the renal physiology, in which today's class let us discuss about the renal handling of sodium and the water. As you all know, I am your Manoj. So, in the previous classes, we have learnt of the formation of glomerular filtrate in the glomerulus and Bowman's capsule. So, therefore, further in this class, we have to discuss about the reabsorption that takes place in the various parts of the nephron, that can be the PCT, loop of Henle and DCT and collecting ducts. So let's begin our class today about the renal absorption of sodium and the water. So now the sodium is reabsorbed from the different parts of the nephron. So the sodium reabsorption can be asked for a 10 marker question along with the water. So it's very important in the point of the exam also. So now let us learn about the reabsorption of sodium, in which it is a 67% is reabsorbed in the PCT, 20% is reabsorbed in the loop of Henle, 7% is reabsorbed in the DCT, and 5% is reabsorbed in the cortical collecting ducts. The reabsorption of sodium in the PCT. So here the reabsorption is isomatic, means the reabsorption of the sodium, means the amount of reabsorption of sodium will be equal to the amount of reabsorption of water. Here we can divide the reabsorption in PCT into two parts, that is the early PCT and the late PCT. In the early PCT, the reabsorption is only transcellular. The transcellular means the reabsorption is through the cells. And one more word we use, that is paracellular. Paracellular transport means the transport between the two adjacent cells of the proximal convoluted tubule. So here in the early PCT, the reabsorption is an active process which is mediated by the sodium potassium antipode and sodium glucose sympode. So I will explain this with my own simple diagram, in which you can use the same diagrams for when you are writing the answers. Now just have a look at this picture, in which this is the part where our glomerular filtrate is flowing in the PCT, and here this is the apical membrane of the PCT cells, and this is the basolateral membrane of the PCT cells. And here our sodium hydrogen antipode system is located on the apical membrane, and sodium glucose sympode is located on the apical membrane, and the sodium potassium ATPase pump is located on the basolateral membrane, and the bicarbonate and sodium co-transport is located on basolateral, and the glucose will be exported into the blood, capillary blood, via the basolateral membrane. Now when the sodium has to be reabsorbed into the capillary blood, so which the sodium and hydrogen antipode is used, in which the sodium is reabsorbed into these PCT cells, and the hydrogen is secreted into the filtrate. And again, one more method is the sodium and glucose sympode, where both the sodium and glucose is entered into the PCT cells, and further this sodium which entered will be exported out into the blood via the using the ATP, that is the sodium potassium ATPase pump, by which it is entered, and along with some of the sodium is entering the blood via the bicarbonate and sodium sympode method. Here, the reabsorption is both transcellular and paracellular. Paracellular is by the chlorine-driven sodium transport, and the transcellular is by the sodium hydrogen antipode, and one more new thing is chlorine formate antipode. Let us discuss this in detail now. So here the paracellular transport, in which the sodium is reabsorbed mainly by the chlorine driven sodium transport mechanism. What is this sodium driven transport mechanism? In the early part of the PCT, we have seen most of the bicarbonate is reabsorbed. Now what is remaining here is the chlorine in the large quantity in the PCT, that is glomerular filtrate on in the PCT. Now the chlorine therefore is reabsorbed via paracellular transport. While reabsorption of this chlorine, the sodium is also reabsorbed along with the chlorine via paracellular. Yes, now the transcellular transport is same as that takes place in the early PCT. Here there are as the sodium and hydrogen antipode system, and the additional one is the formate and chlorine antipode system. So there is so much of chlorine is present in the filtrate which has to be reabsorbed into the blood, and it is achieved by this formate and chlorine antipode system, and our sodium is also absorbed via the sodium and hydrogen antipode system. Further, this sodium enters this blood via the potassium and sodium ATPase pump, and this chlorine also enters into the blood via the potassium and chlorine symport. As the filtrate passes into the next segment, that is the loop of Henle, it has the three parts, that is the descending limb, ascending thin segment, and a thick ascending limb. Here in the descending limb, the sodium is reabsorbed passively into the interstitium. In the ascending thin segment, it is again passively secreted into the interstitium, whereas the thick ascending limb, it is by the sodium hydrogen antipode and sodium potassium and chlorine symport. Here the additional one is the sodium potassium chloride symport. As you all know, this segment is common, that is the antipode, sodium hydrogen antipode, and the new additional one is the sodium chlorine potassium symport, which is located in the thick ascending limb. This is in which the sodium and potassium is symported along with the two chlorine atoms along when they are entered into the PCT cells. Further, this sodium is entered into the bloodstream via the potassium and sodium ATPase pump, and the chlorine and potassium as which they entered into the blood. The next segment we have is the DCT and the collecting duct. So we can understand this DCT and collecting duct into two segments, that is the early DCT and the late DCT, and the collecting duct. We have almost the same type of the reabsorption processes. Coming to the early DCT, it is the active process and the sodium chlorine symport takes place. Let us see how in detail now. So here we don't have the sodium and the hydrogen antipode. It is replaces by the sodium and chlorine symport mechanism, by which the sodium enter into the PCT cell. Further, this sodium enters the bloodstream via the potassium and sodium ATPase pump, and the chlorine which entered will directly enter it reabsorbed into the blood, by which the sodium from this filtrate enters into the blood. In the late segment of the DCT and the collecting duct, the sodium is reabsorbed by the active process, and here it is under the regulation of aldosterone. During the excessive loss of water, the ionic imbalance is created, so the sodium concentration in the blood is decreased, during which the aldosterone is released. This aldosterone which is released will act on the late part of the late segment of the DCT. Now let us see in detail how it acts. So now the aldosterone which acts on the late compartment of the DCT, which increases the sodium reabsorption into the principal cells, and further this sodium which is reabsorbed into the bloodstream via the sodium potassium ATPase pump, and meanwhile the potassium is secreted into the GFR, and the hydrogen is here, the potassium and hydrogen, they are secreted and reabsorbed to balance the osmolarity. And coming to the intercalated cells or the early part of the collecting duct, here it should be a sodium. It's a printing mistake. So the sodium is reabsorbed into the intercalated cells, and further it is enters into the bloodstream, and the bicarbonate also enters the bloodstream to maintain the osmolarity. So that is about the reabsorption of the sodium. So it is a 10 marker question. It will be asked along with the reabsorption of the water. Now let us see about the reabsorption of the water. What is the site and what are the mechanism? Water is passively absorbed by the osmosis in response to the transtubular osmotic gradient. The rapid reabsorption across the cell membrane occur through the water channels. They are made up of, these water channels will be made up of the aquaporins. So these aquaporins, which are helpful in the reabsorption of water, they are situated on the different segments of the nephron. In DCT, the reabsorption is controlled by the DCT. In the DCT, the reabsorption is controlled by the ADH hormone. And the aquaporins, they are aquaporin 1, 2, and 5 and 9. In the PCT, nearly 67% of the water is reabsorbed passively along with the sodium. In the descending thin segment, the 15% of the water is reabsorbed passively. And coming to the ascending thin segment, this ascending thin segment is impermeable to water and it is permeable to solutes. So the water reabsorption is not possible in this segment. Even the thick ascending limb is also impermeable to water, and DCT is also impermeable to water, but it is permeable to water under the effect of ADH. And the collecting tubule and cortical collecting duct and outer medullary collecting duct, inner medullary collecting duct, all together it contributes to 18 to 70% of the reabsorption of water. Obligatory reabsorption. The obligatory reabsorption means the compulsory reabsorption. Without any fail, that amount of water always will be reabsorbed. That is, the 80% is all of water is always reabsorbed irrespective of body water balance, and it occurs by the osmotic gradient. In that, 67% of water is reabsorbed in the PCT and 15 to 18% is reabsorbed from the descending thin segment of the loop of Henle. Next is the facultative reabsorption. It is the optional reabsorption, means sometimes there the reabsorption takes place and sometimes it is altered, and it is by the effect of antidiuretic hormone or vasopressin is so this antidiuretic hormone or vasopressin is secreted by the supraoptic nuclei of the hypothalamus. Further, it is stored sometimes in the anterior posterior pituitary, and further it is released, and which acts on the distal part of the DCT. Right. So in this facultative reabsorption, 15 to 18% of the water may or may not be reabsorbed depending upon the body water balance. So when the ADH acts, it is reabsorbed. Yeah, thank you very much for your patience, and this is one of the very important topic that we have discussed today. Please do read this topic. It is one of the most expected question which will be asked as a long essay. So stay tuned with us. Do like, share and subscribe. Thank you. See you in the next video.